So hello, welcome to our video presentation for the course Introduction to Mathematical Economics. In this video, we will discussing a national income model and how mathematical methods are used to analyze relationship between income, consumption, and taxation in an economy. This presentation is prepared by THARANI, ALEEYA, FARISYA, ADLINA, SYAMIMI, and me, AISYAH. The assignment is conducted under the guidance of Professor Madya Dr. Nur Azam bin Abdul Razak. Let's begin with the model given in this assignment. We are provided with three equations, which is the income identity, the consumption function, and the tax function. In this model, Y represents aggregate income, C represents consumption, and T represents tax. The parameters B and T indicate the marginal propensity to consume and the tax rate, where both values lie between 0 and 1. These equations together explain how income is generated and distributed within the economy. Based on this model, our objectives are divided into three main parts. First, we form a system of three simultaneous equations involving the endogenous variable of y, c, and t. Second, we transform this equation into metric form. And the third is, we solve the equilibrium value of y, c, and t using three different methods, which is the metric inversion method, Cramer's rule, and the variable substitution method. Through this video, we aim to explain each step clearly and systematically.
Hi, my name is THARANI KUMAR. My matrix number is 310253. Now, I will continue our presentation with the first question, which is form a system of three simultaneous equations in three endogenous variables, which is y, c, and t. First equation is the income identity. Income y is equals to consumption plus autonomous investment plus autonomous government expenditure. So, y equals to c plus I sub 0 plus g sub 0. Next, I rearrange this equation by bringing c to the left hand side. So, it becomes y minus c equals I sub 0 plus g sub 0. Second equation is the consumption function. Consumption C is equals to autonomous consumption plus marginal propensity to consume times disposable income. So, C equals to C sub 0 plus B times Y sub D. Disposable income Y sub D is income minus tax. So, I substitute Y sub D with Y minus T. Now, the equation becomes C equals to C sub 0 plus By minus Bt. Next, I arrange the equation by bringing all variables to the left-hand side. So, it becomes C minus By plus Bt equals to C sub 0. Third equation is the tax function. Tax T is equals to autonomous tax plus proportional tax times income. So, T equals to T sub 0 plus Ty. I rearrange the equation by moving Ty to the left-hand side. So, it becomes T minus Ty equals to T sub 0. The next question will be transform the above three simultaneous equations into the matrix form. Let Ax equals to D, where A is the matrix of coefficients, X is the vector of endogenous variables, and D is the vector of constants. From the first equation, y minus c equals to I sub 0 plus g sub 0, the coefficients are 1 for y, negative 1 for c, and 0 for t. From the second equation, c minus by plus bt equals to c sub 0. The coefficients are negative b for y, 1 for c, and b for t. From the third equation, t minus ty equals to t sub 0. The coefficients are negative t for y, 0 for c, and 1 for t. Now, I write the matrix form. The coefficient matrix A is first row 1, minus 1 and 0. Second row minus b, 1 and b. Third row minus t, 0 and 1. The vector for variables x is y, c and t. The constant vector d is I sub 0 plus g sub 0, c sub 0 and t sub 0. Therefore, the matrix equation is Ax equals to D.
Hi, my name is NURUL FARISYA BINTI ABDUL JAMIL. Matrix number is 310157. Now, we move to the next formal solution phase since we have successfully transformed our national income equations into the matrix form. Ax equals T. Our goal is to isolate the endogenous variables, equilibrium income Y star, consumption C star, and tax T star. To do this, we apply the matrix inversion method, which relies on the fundamental identity. Vector x equals 1 over the determinant of A times the adjoint of A times the constant vector D. The first critical step is obtaining the determinant of A, also known as modulus. We perform a Laplace expansion along row 1 of our coefficient matrix. First, we take the element 1 from the first row and first column. We multiply it by the determinant of the remaining 2 by 2 minor. 1 times 1 minus 0 times b, which gives us 1. Next, we subtract the second element, which is negative 1. We multiply it by the minor created by deleting row 1 and column 2. Negative b times 1 minus b times negative t. This simplifies to negative b plus bt. The third element is 0, so the entire term disappears. Combining this, we get 1 plus the quantity negative b plus bt. Factoring out the b, our final determinant is 1 minus b times the quantity 1 minus t. We must assume that this expression is not equal to 0, confirming that matrix A is non-singular and invertible. Next, we calculate the cofactor matrix C, which requires finding the minor for all 9 positions. In the first row, C11 is 1, C12 is the expansion B times the quantity 1 minus T, and C13 is T. In the second row, we delete the middle rows and columns to find C21 is 1, C22 is 1, and C23 is T. In the third row, finally, we find C31 is negative B, C32 is negative B, and C33 is 1 minus B. Once the cofactor matrix is complete, we perform a transpose operation flipping the row into column to arrive at the adjoint of A, which we see here as equation 11. Now, we perform the final multiplication, A inverse times vector D. To find Y star, we take the first row of our adjoint and multiply it by the constants in vector D. This is 1 times the quantity I sub 0 plus G sub 0 plus 1 times C sub 0 plus negative B times T sub 0. This gives us our first equilibrium. Y star equals C sub 0 minus B times T sub 0 plus I sub 0 plus G sub 0, all divided by the determinant. To find C star, we use the second row of our adjoint. We multiply B times the quantity 1 minus T by the autonomous spending, then add 1 times C sub 0 and negative B times T sub 0. The result is C star equals the quantity C sub 0 minus B times T sub 0 plus B times the quantity 1 minus T times the quantity I sub 0 plus G sub 0 all over 1 minus B times the quantity 1 minus T. Lastly, we determine the equilibrium text T star by multiplying the third row of our adjoint by vector T. We multiply T times the quantity I sub 0 plus G sub 0, then T times C sub 0, and finally the quantity 1 minus B times T sub 0. By rearranging these terms, we reach the final expression. T star equals T sub 0 times the quantity 1 minus B plus T times the quantity C sub 0 plus I sub 0 plus G sub 0 divided by our common denominator. This completes the matrix inversion method, providing us with a full simultaneous solution for the national income model.
Assalamualaikum and hello everyone. My name is ADLINA SYAMIMI BINTI YUSOF and my metric number is 310186. So based on the system of equations and the metric form that have already been explained by my group members, we can now proceed to solve the model using Kramer's rule, which is the second method under part C. So basically, Kramer's rules is a technique in linear algebra that allows us to solve a system of simultaneous equations by using the determinants. In our case, we are solving for three endogenous variables, which is the aggregate income Y, consumption C, and tax T. So first, we recall that the coefficient matrix A is made up of three rows. The first row is 1, -1, and 0. The second row is negative B, 1, and B. The third row is negative T, 0, and 1. The constant matrix D consists of three rows as well. The first row is I sub O plus G sub O. The second row is C sub O. The third row is T sub O. So Kramer's rule states that each variable can be solved by replacing one column of matrix A with the constant matrix D. Calculating the determinant and dividing by the determinant of A. So let us begin with the Y star. To find Y star, we replace the first column of A with a D, forming matrix A sub Y. It is in the first row is I sub O plus G sub O, -1 and 0. Second row is C sub O, 1 and B. Third row is T sub O, 0 and 1. After calculating the determinant, we obtain the following result is Y star equals open bracket C sub O minus B times T sub O plus I sub O plus G sub O close bracket. And then we divided it by 1 minus B times open bracket 1 minus T close bracket. Next, we move on to C star. To find C star, we replace the second column of A with a D, forming matrix A sub C. It is in the first row is 1, I sub O plus G sub O and 0. Second row is negative B, C sub O and B. Third row is negative T, T sub O and 1. The determinants give us the following result. C star equals to C sub O minus B times T sub O plus B times open bracket 1 minus T close bracket times open bracket I sub O plus G sub O close bracket. And then we divide it by 1 minus B times open bracket 1 minus T close bracket. Finally, we calculate T star. To do this, we replace the third column of A with a D. Forming matrix A sub D, it is in the first row is 1, negative 1, and I sub O plus G sub O. Second row is negative B, 1, and C sub O. Third row is negative T, 0, and T sub O. The determinant gives us the following result that T star equals to T sub O times open bracket 1 minus B close bracket plus T times open bracket C sub O plus I sub O plus G sub O close bracket. And then we divide it by 1 minus B times open bracket 1 minus T close bracket. To sum up, Cramer's rule provides a systematic way to solve for Y star, C star, and T star by using the determinants. It is especially useful when dealing with a system of equations like our national income model. So thank you for listening. I hope this explanation has helped you understand how Cramer's rule is applied in this context.
My name is Siti and my metric number is 310252. And I will move on to the variable substitution method. In this method, we solve the equation step by step by substitution. We start with the definition of disposable income. Y sub D equals Y minus T. This means disposable income is total income minus tax. The original consumption function is C equals C sub 0 plus B times Y sub T. Now we substitute YT equals to Y minus T into the consumption function. So the equations become C equals to C sub 0 plus B times open bracket Y minus T close bracket. Next, we substitute the tax function. The tax function is T equals to T sub 0 plus T times Y. Substituting this into the consumption equation gives C equals to C sub 0 plus B times open bracket Y minus open bracket T sub 0 plus T times Y close bracket. Now, we simplify the expressions. C equals to C sub 0 plus B times open bracket 1 minus T times Y minus T sub 0 close bracket. So next, we substitute the consumption function into income identity. The income identity is Y equals to C plus I sub 0 plus G sub 0. Substituting the value of C gives Y equals to C sub 0 plus B times 1 minus T times Y minus B T sub 0 plus I sub 0 plus G 0. Now we rearrange the equation by bringing all Y terms to the left-hand side. Y minus B times 1 minus T times Y equals to C sub 0 minus B T sub 0 plus I sub 0 plus G sub 0. So next, we factorize Y. Open bracket 1 minus B times open bracket 1 minus T close bracket times Y equals to C sub 0 minus B T sub 0 plus I sub 0 plus G sub 0. Finally, we divide both sides by 1 minus B times 1 minus T to obtain equilibrium income. So Y stars equals open bracket C sub 0 minus B T sub 0 plus I sub 0 plus G sub 0 close bracket divided by open bracket 1 minus b times open bracket 1 minus t close bracket close bracket. Thank you for watching our presentation. We hope our explanation has provided a clear understanding of the national income model and the method used to solve it. Thank you once again for your time and consideration.